In the unforgiving calculus of undersea warfare, there are no second chances. The deep ocean is a realm of absolute physics where pressure crushes and sound travels with lethal clarity. It is an environment that ruthlessly exposes the slightest flaw in design or execution. Here, every bolt, every hull panel, and every line of code can be the sole determinant between a ghost in the depths and a tomb of twisted metal. It is into this arena that a new and profoundly disruptive actor emerges: the AJX-002, a 20-meter-long, extra-large, uncrewed undersea vehicle, XLUUV, that represents not merely an evolution in naval technology, but a revolutionary convergence of capabilities that fundamentally redefines the nature of a strategic asset. While platforms like the U.S. Navy's Boeing Orca represent a logical and necessary step towards augmenting the fleet with unmanned systems for missions like mine-laying and reconnaissance, the AJX-002 is a conceptual leap into an entirely new domain of autonomous, persistent, and strategically significant presence. Its development was born from the pressing anxieties of a new era of great power competition, recognizing the inherent limitations of crewed submarines in maintaining constant clandestine vigilance in the contested littorals and vast empty basins of the world's oceans. The very existence of such a platform signals a doctrinal shift of immense consequence, moving away from a purely human-centric model of naval conflict towards a hybrid framework where autonomous systems are entrusted with the most perilous and enduring missions. This implies a level of confidence in artificial intelligence and autonomous decision-making for lethal applications that goes far beyond simply building a larger drone. It suggests a willingness to accept or a belief that one has solved the black box problem of AI in warfare, a challenge that remains a formidable barrier for military planners worldwide. The AJX-002 is, therefore, less a piece of hardware and more a statement of intent, a harbinger of a future where the most critical contests may be waged by silent, thinking machines in the crushing dark. The vehicle's architecture is a masterclass in purpose-driven material science, a 20-meter bus-sized frame engineered to conquer depth while cheating detection. At its core lies a pressure hull fabricated from a high-strength titanium alloy, a design philosophy that echoes the deep-diving legacy of Russian submarines like the Alpha and Sierra classes, which prioritized operational depth above all else. This titanium heart grants the AJX-002 a staggering operational depth capability, estimated to exceed 1,000 meters, placing it in an exclusive club occupied only by specialized research submersibles and strategic platforms like Russia's Poseidon UUV. This pressure-resistant core is, however, encased within a free-flooding outer hull constructed not of metal, but of advanced non-metallic carbon fiber and aramid composites. This dual-hull approach is a radical solution to the classic submarine design trilemma of balancing depth, cost, and stealth. The outer composite shell serves multiple critical functions. Its carefully molded contours provide a hydrodynamically ideal shape that minimizes flow noise and maximizes energy efficiency. It is acoustically transparent to the vehicle's own powerful sensor arrays, preventing self-interference. And crucially, it possesses a near-zero magnetic signature, rendering it exceptionally difficult to pinpoint using magnetic anomaly detectors. MED, a primary tool in aerial anti-submarine warfare. This fusion of distinct naval engineering philosophies, the Russian penchant for costly, deep-diving titanium hulls, and the Western focus on composite materials for acoustic and magnetic discretion, as seen in elements of the Royal Navy's Astute-class submarines, creates a system greater than the sum of its parts. It is, however, a solution that brings its own set of engineering nightmares. The interface between the titanium and composite structures, each subject to different thermal expansion coefficients and stresses under extreme pressure cycling, would be a constant point of potential failure, likely requiring maintenance routines so complex they border on the ritualistic. To complete its physical stealth profile, the entire structure is clad in a multi-layered, next-generation anechoic polymer tile system. This is a significant advancement on the Albrecht coating first developed by the Kriegsmarine in World War II. Unlike their predecessors or even modern coatings on crewed submarines, these tiles are not uniform. Their composition, thickness, and the density of their internal voids vary across the hull, specifically tuned to absorb and scatter the precise sonar frequencies used by the most modern anti-submarine threats, from the low-frequency active sonar of surface ships to the high-frequency pings of torpedo guidance systems. The heart of the AJX-002's unprecedented endurance, the very feature that elevates it from a tactical tool to a strategic weapon, is its revolutionary power plant. It is built around a compact liquid metal-cooled fast reactor, a design that shares a conceptual lineage with the propulsion system of the Poseidon. Unlike the large pressurized water reactors that power naval ships and submarines, which are optimized for high power output, this reactor is purpose-built for an unmanned platform. Its design prioritizes extreme compactness, low thermal output for stealth, and passive safety features that can ensure stability without human intervention. This nuclear core provides a virtually unlimited operational range, freeing the vehicle from the tyranny of fuel logistics that constrains every conventional platform. However, the true innovation lies not in the reactor itself, but in its hybrid integration with a secondary power system, a massive bank of pressure-tolerant, high-energy density lithium-ion batteries. These modules, conceptually similar to Kraken Robotics' Sea-Power batteries, which encapsulate cells in a pressure-tolerant polymer matrix, allow the AJX-002 to execute a tactic no other nuclear-powered vessel can. For extended periods, potentially lasting days or even weeks, it can shut down its reactor and all associated cooling pumps, the primary source of a nuclear vessel's irreducible acoustic signature, and operate in a state of near absolute silence on battery power alone. This ultra-quiet mode is the key to its ability to clandestinely infiltrate heavily monitored choke points or to loiter undetected while tracking a high-value target. This capability represents a monumental advantage over both conventional XLUUVs like the Boeing Orca, whose diesel-electric system offers a finite range of around 6,500 nautical miles and requires snorkeling to run its diesel generators, and submarines equipped with air-independent propulsion, AIP systems, which can remain submerged for only a few weeks at very low speeds before their oxidants are depleted. The hybrid reactor battery system effectively combines the strategic persistence of a nuclear submarine with the tactical acoustic discretion of a battery-powered one, creating a profound ambiguity for enemy ASW forces. A faint acoustic contact could be a small, short-range UUV, or it could be the AJX-002 playing dead before re-engaging its reactor in the open ocean to recharge and reposition. This tactical flexibility, the ability to choose its own acoustic signature to match the threat environment, is a game-changing capability. Propulsion is delivered through a shrouded pump jet, a design inherently quieter than a conventional propeller that minimizes the onset of cavitation, the noise-producing bubbles that are a dead giveaway to passive sonar systems. Operating entirely within the deep, GPS-denied environment of the ocean, the AJX-002 relies on a sophisticated, multi-layered, and AI-driven autonomous navigation suite to chart its course through the abyss. The foundation of this system is a high-precision ring laser gyroscope inertial navigation system, INS, a standard for modern submarines that tracks the vehicle's every turn and acceleration to constantly update its position. However, the fundamental law of inertial navigation is that all such systems, no matter how precise, suffer from cumulative error drift over time. To continuously correct this drift without surfacing for a GPS fix, the AJX-002's primary tool is an advanced form of terrain contour matching, TERCOM. Unlike the radar altimeter-based TERCOM used by cruise missiles, this underwater variant employs the vehicle's high-resolution synthetic aperture sonar, SAS, to generate a real-time, three-dimensional map of the seabed below. This dynamically generated map is then continuously compared against a massive onboard database of preloaded bathymetric charts. The true breakthrough, however, lies in the vehicle's central AI core, which acts as the master navigator. Running advanced pathfinding and heuristic search algorithms like a modified A or D light, the AI's role is not just to follow a pre-programmed route, but to actively engage in the process of navigation. It fuses the data streams from the INS and the TERCOM system, achieving a navigational accuracy measured in mere meters over missions that can last for months. This AI-driven sensor fusion is what makes the system resilient. TERCOM is highly effective, but it has known limitations. It fails in areas with flat, featureless seabeds and can be confused by inaccurate or outdated map data. The AJX-002's AI is designed to manage these limitations. It can assess the quality of the seafloor for a TERCOM fix. If the terrain is unsuitable, it can intelligently switch its reliance to other inputs, using its MAD sensor to detect the magnetic signature of charted undersea cables, or using its passive acoustic array to triangulate the positions of surface vessels, to provide an auxiliary position fix and update the INS. It can even make the tactical decision to enter a low-power loiter state, drifting with a current until it enters a region with more distinct bathymetric features to obtain a high-confidence position update. This is the critical difference between simple automation and true adaptive autonomy. The vehicle is designed for both persistent reconnaissance and decisive strike, requiring a sensor suite that is a marvel of stealth integration. Its primary intelligence gathering tool is the conformal synthetic aperture sonar (SAS) array, seamlessly integrated into the composite outer hull. This system provides near photographic quality imagery of the seabed, allowing for clandestine mapping, mine detection, and the identification of undersea infrastructure with unprecedented resolution. To hunt other submarines, its most potent sensor is a miniaturized, highly sensitive magnetic anomaly detector, MAD, housed in a retractable tail boom to isolate it from the vehicle's own minimal magnetic field. This is a compact, scaled-down version of systems like the CAE MAD-XR, which have been successfully miniaturized for use on drones and helicopters. The vehicle is also equipped with a full suite of passive acoustic hydrophones and environmental sensors that constantly monitor water temperature, salinity, and pressure. This data is fed directly to the AI, which uses it to practice a form of active stealth management. The AJX-002 is not just a quiet platform, it is a platform that actively seeks out and exploits the ocean's own properties to become quieter. The AI can process terabytes of oceanographic data in real time to calculate the optimal depth and course to minimize its probability of detection, for instance, by hiding beneath a thermocline or within an acoustic shadow zone. Its stealth is therefore not a static design feature, but a dynamic state that the vehicle constantly works to optimize. The ultimate purpose and most disquieting feature of the AJX-002 is its armament, housed within a modular central payload bay. In its primary strike configuration, this bay contains a compact 6-cell vertical launching system, VLS. This VLS employs a cold launch mechanism where a gas generator ejects the missile canister from the launch tube before its rocket motor ignites clear of the vehicle. This method is inherently safer than a hot launch system and, critically, minimizes the acoustic transient of the launch, making it far more difficult for an adversary to detect and localize the firing event. The primary armament is a new class of tactical delivery vehicle armed with a variable-yield nuclear warhead. This weapon is a direct technological descendant of the highly miniaturized tactical nuclear devices of the Cold War, such as the W-54 warhead used in the Davy Crockett system, which packed a yield of 10 to 20 tons of TNT into a package weighing just over 50 pounds. Leveraging decades of advances in material science, electronics, and fissile material compression, the AJX-002's warhead features a selectable yield, ranging from as low as 0.1 kilotons for a highly precise low collateral strike, up to a maximum of 50 kilotons for engaging hardened underground facilities or concentrated naval formations. This payload deliberately positions the AJX-002 as a tactical counterforce weapon, a stark and strategically significant contrast to the multi-megaton, city-destroying thermonuclear warhead of the Russian Poseidon. This choice of a low-yield, precision-guided, and deniable nuclear weapon is arguably the vehicle's most destabilizing characteristic. It deliberately blurs the line between conventional and nuclear warfare. A weapon like Poseidon is an unambiguous doomsday device, a weapon of last resort. A small nuclear strike from a stealthy, unmanned, and potentially unattributable platform could be perceived by some military planners as a usable nuclear option in a limited conflict, an action designed to de-escalate a crisis through a shocking but contained demonstration of force. This possibility dramatically lowers the nuclear threshold and presents an adversary with a terrifying and perhaps paralyzing escalation dilemma. The modularity of the payload bay also allows the AJX-002 to be reconfigured for other missions, such as deploying a swarm of smaller UUVs, launching conventional torpedoes against surface or subsurface targets, or carrying an expansive, non-lethal intelligence, surveillance, and reconnaissance package. The operational doctrine enabled by the AJX-002 is transformative. It can be deployed from a pier, transit autonomously across thousands of miles of open ocean to its designated patrol area, and remain on station for months at a time, a silent, patient sentinel. Its potential missions are Legion conducting persistent, close-in surveillance of enemy naval bases, clandestinely mapping the bathymetry of denied littoral zones to prepare for future amphibious operations, acting as a covert survivable communication node for a distributed network of assets, or holding critical coastal infrastructure and enemy naval fleets permanently at risk. Its very existence poses a direct challenge to the current generation of Western XLUUVs, such as the U.S. Navy's Orca and Australia's Ghost Shark, which are non-nuclear and designed for more conventional support roles rather than strategic strike. Of course, the development of such a complex and ambitious system would inevitably be a torturous affair, a journey fraught with the kind of staggering cost overruns, technical failures, and programmatic delays that plagued other revolutionary platforms like the Zumwalt-class destroyer or the naval variant of the F-111. It is not hard to imagine that the project was saddled with a grandiose, unpronounceable acronym by a committee of bureaucrats, and that the first 5 prototypes now reside quietly at the bottom of a test range, having succumbed to a fatal software bug or a seemingly insignificant leaky seal. Yet, the strategic imperative remains. The primary impact of a successfully deployed AJX-002 fleet would be the creation of a new form of unmanned deterrence. It would force adversaries into an unsustainable cost-exchange ratio, compelling them to expend enormous and continuous resources on anti-submarine warfare to counter a threat that is persistent, patient, and entirely non-human. An adversary would have to maintain a constant, high-alert ASW screen across vast swaths of ocean to guard against a single platform that is, in the grand scheme of strategic weapons, relatively inexpensive. This dynamic could trigger a new, silent, and entirely robotic undersea arms race, a continuous, low-intensity conflict waged by algorithms in the deep ocean, completely invisible to the world on the surface. In conclusion, the AJX-002 represents a true paradigm shift, a physical manifestation of the convergence of miniaturized nuclear power, advanced material science, and genuine artificial intelligence. It is a platform whose future modernization path is defined less by shipyard refits and more by software updates. Future upgrades could see the integration of quantum sensors for navigation entirely independent of external references, like the seabed, advanced networking protocols enabling swarm operations with other unmanned assets, and the development of new payload modules carrying hypersonic anti-ship missiles or even directed energy weapons. The AJX-002 is more than a machine. It is the embodiment of a new era in naval conflict, one where the arms race moves from the factory floor to the software lab. It poses profound and deeply uncomfortable questions about strategic stability, the lowering of the nuclear threshold, and the very future of warfare itself.